Hey everyone, in this video we're going to look at how we calculate two measures of spread, population and sample variance, and population and sample standard deviation, and they're very closely related to each other. Definition for population variance, the symbol for it is sigma, Greek letter for s squared, and you get a sigma notation expression over here, so we're going to be adding up a bunch of stuff. So we're going to add up each value in the data set minus the mean. Might be more accurate on this to put x of I down there for each of these. And we'll take each value in the data set minus the population mean, this is letter mu in Greek, squared, add up all those for every data value, and then we're going to divide by how many we have in our population. Definition for sample variance down here is almost identical, except the lettering is different. We're going to talk about the sample mean, which is x bar, and then we're going to divide by one fewer than the number in our sample size. Now think about what this calculation, we're going to add a bunch of stuff up, and then we're going to divide by how many we have. So this is an average, and it's the average of what we're adding up. So it's the average difference from the mean squared for every data value. Down in sample variance, it's the same thing. We're going to divide by one smaller, so we're dividing by n minus 1 in this. And so it's going to give us a little bigger value, but if you stop and think about it, it makes sense. If we're measuring how spread out our data is, and we just grab a sample, this number is going to be bigger than the calculation for the population, and that makes sense. There's a better chance that we have a more spread out sample than the population actually is. So that's why they do that. Standard deviation is going to be the square root of this. So if sample variance is the average distance from the mean squared, then sample standard deviation is approximately the average distance from the mean for each of our values. That's really nice. So it gives an indication of about how far away each of these data values is on the average. And then population standard deviation has the letter sigma, and it is also just the square root of this expression up here, so I'm not going to write the whole thing out, but this is one of those pieces of notation math that's kind of cool, is that, I can't really see my smiley face there, but standard deviation, sigma, is the square root of sigma squared. So that works out nicely for us. Here's a sample calculation I'll go through. You notice I set up a table for this. I think it helps organize what's going on in this kind of messy formula. So first thing we're going to do is to find the average distance from the mean squared. Let's just find the mean of all of our values. Now write down all our values in this first column. So 12, 20, 16, 18, and 19. Average salaries at Jersey Junction for a sample. So we go through and add those up, and you get 80 divided by 5 is 17. So the average of all of our salaries is 17. So we want to know how far away these values are from the mean on the average. So let's find out these values, differences. These are called the deviations in this column, each value minus the mean. So 20 minus 17 is 3, 16 minus is negative 1, 18 minus 17 is 1, 19 minus 17 is 2. And take a moment and notice the total of this column, if we want to find the average of these deviations, is going to be 0. And that makes sense because we should have the same amount on either side of our mean. That's why we're squaring in this case. So we're going to get rid of these negative signs so we can actually find an average. So 25, 9, 1, 1, and 2. And if I add this column up, oops, not 2, 4. If I add this column up, I'm going to get my numerator. I'm going to get the total of all the deviations squared. So this total is 40. And now if we go to our formula, sample variance is going to be the total of our deviations squared, which is 40, divided by, I have 5 numbers in my data set, minus 1. And so I get a variance of 10. We talk about the hours, or the units here. The units of our values were dollars, and then we subtracted, and we have negative $5 below the mean, and then this is $25, but we squared it, and then we totaled it. So that's the units of our variance. It's kind of a weird unit, but This is dollars squared. And then to find our sample standard deviation, take the square root of that. So square root of $10 would be our standard deviation. 3 point something. Let me check out what that is on the calculator. So this sample variance, on the average, the distance squared from the mean is 10. Sample standard deviation, on the average, our values are about 3 units away from the mean. This one's 5 below, this one is about 3, and then we have some that are fewer than that. So square root of 10 is our sample variance, our sample standard deviation, and so that's about 3.8, 3.16 dollars. Now we can use our calculators to quickly find this, just like we can with mean and median. If we put our data into a list, so 12, 20, 16, 18, 19, our 5 salaries, and then we go into stat menu and over to calculate. The one variable stats gave us this before, and so we can look at this now and see what we get. Now we actually know what these symbols mean. Here is the S with a little x subscript. This is the standard deviation for the sample. I just remember S for sample, and then this little guy looks like a flipped around P on here, so that's our population. That's really just a sigma, and this would be the calculation that you would get if you divided by n instead of n minus 1.